The HOMMEL gauge line gauging system is the first measuring machine combining full automatic dimensional measurement and surface testing of camshafts. In the case of the pump nozzle camshaft shown here, both the valve cams and the pump cams between them, as well as all bearings, are tested. The camshafts are tested for dimensional accuracy and presence of quality errors. The HOMMEL gauge line measuring system is designed as a standalone machine with an internal modular structure, in this case featuring 3 stations. Surface testing of the camshafts takes place in Station 1. The complete component is measured fully automatically with highest accuracy in Station 2. Station 3 provides laser marking of the OK camshafts with a data matrix code. The HOMMEL gauge line measuring system tests the surface of all cams, the bearings and the thrust walls for the presence of any faults. The surface test is the first test to take place in Station 1. The camshaft is lifted from the belt, clamped between 2 centers and goes through a full rotation in order to provide the complete surface around the circumference. During rotation, the designated test areas are recorded simultaneously by 8 cameras. A picture of every cam pair, including the pump cam between them, is recorded. The actual image shows a picture of a full 360 degrees travel of the 3 cam surfaces. This screenshot shows the bearing surface images of a full revolution. The left and right thrust walls are simultaneously recorded by a special camera that, needless to say, also records the image of the entire circumference. The HOMMEL system software evaluates the recorded images fully automatic. Each individual cam surface is divided into different individual test zones. Each of the specified test zones can be examined using different evaluation characteristics. The system determines the size and position of existing surface flaws. The software is able to determine and classify the surfaces according to criteria such as flaw size, distance between flaws, positions of the flaws, accumulation of flaws, type of fault, etc. The user can change all test parameters easily, so that the measuring system can be adapted quickly to new requirements. The test results are summarized in a detailed test statistics. This provides extensive documentation of the quality of the tested camshafts. The tested parts are then transported to Station 2, the measuring station. In this station, the camshaft is lifted from the transportation belt, positioned and clamped between centers. The rotary driver is fitted and turned by a rotational segment until it snaps into the conical groove. The rotary drive positions this unit in the 0 position or starting position for measurement. The measurement covers 360 degrees. The rotary driver, the rotational unit and the centers move back and apart into their home position. The measured camshaft is placed back on the prisms of the transport belt. In the meantime, the recorded data is evaluated and gets compared to the specified tolerances. The measurement results are displayed depending on the screen selection. Main dialog box with display of the different evaluation possibilities. For example, with characteristics of all selected and programmed measurement positions. Polar diagram of the single cams. Polar diagram of all main bearings. Circular form deviation linear of the main bearing. Envelope line of the cams in axial direction. Straightness of the cams in axial direction related to the axis AB. Circular form deviation polar of all cams. Linear diagram of the cam form deviation. Roundness of the main bearing. The measuring station is adjusted automatically by the setting master parked above the station, either at the end of a set time or quantity or by manual selection. A linearity test is also conducted automatically with a test standard. The measuring machine is ready to measure after successful adjustment and linearity testing. NOK parts from Station 1 and Station 2 are placed on a reject parts belt. The ends of the tested fault-free camshafts are then labeled with a data matrix code by a laser in Station 3. The labeling quality is monitored fully automatically by a HOMMEL data matrix reader. This test software allows inspection of all types of data matrix and also plain text signatures. The labeling quality is tested according to the AIM standard. This guarantees that only flawless and dimensionally accurate camshafts with perfect data matrix code leave the HOMMEL gauge line machine. The flexible concept of the HOMMEL gauge line machine in combination with the latest camera and laser labeling technology allows a wide variety of test and measuring technologies to be united in a compact measuring machine. The gauge line gauging machine is suitable for all kinds of camshafts, eccentric shafts, crankshafts and gear shafts.